Welcome to the Mobilize and FAIR webinar series, and thanks to those of you who have continued on from the research talk. In this portion of the webinar, Parker will share a process and best practices for planning similar large-scale human movement data collection events with OpenCap, including study design, logistics, and data management and sharing. And again, we'll take more questions at the end of the best practice session, and again, use that Q&A panel. Feel free to enter your questions again during the talk. With that, Parker, please feel free to go ahead and start the best practice session.
Okay, thanks, Matt. So in the first part, we already talked about how we've been using OpenCap to collect large-scale data sets for neuromuscular disease and what that's allowed us to discover. Now I'm going to go through a set of 10 steps with our recommendations for how to run your own large-scale data collections with OpenCap. And we are going to post a lot more information about this on the Fair Center website, and so you can receive information about that soon. So I won't go into all of the detailed prescriptions here, but I really want to call out how these steps relate specifically to doing OpenCap studies and share some stories about what we ran into doing our own studies behind the scenes. So the first step in any research project, of course, is to set up your research questions and design your study.
Parker, can you reshare your slides?
Oh, for sure.
They're being shared in the call. Sorry about that.
Let's try this. All right, can you see my slides all right?
Yeah, we see it now.
Great. So step one in your research, to set your research questions. The part of this that's specific to OpenCap is making sure that OpenCap is the right tool for measuring your research questions. So some of those considerations are, can OpenCap measure the degrees of freedom that you're interested in, and is it accurate enough? For our study, we made sure that we had to think about, for example, whether or not to recruit people who were ambulatory. And when we started out, OpenCap required you to stand to calibrate the skeleton. But then they updated it and had added a feature that allows you to scale your kinematic models from a seated position. So that's allowed us to enroll non-ambulatory participants who can at least perform the non-ambulatory tasks in our data set. We also allowed people with orthotics to enroll. We tended to do our measurements both with orthotics and without orthotics so that we could study the differences, but there's no particular reason that orthotics would interrupt the OpenCap data collection. However, other things like assistive devices we excluded from our data collection because they're not really compatible with OpenCap. They can cause occlusions and they're not part of the skeletal model. So something like a rollator or a cane we would exclude, or if a person needed a second person to help them perform a task, we didn't include those. Also important to remember that OpenCap can't, by default, can't measure every degree of freedom in the body. So for example, wrists and spine mobility are not in the default OpenCap skeleton. You could extract those by reprocessing the kinematics yourself. So you could still use OpenCap to do the video data capture and save them onto the cloud, but you would need to reprocess them to get that information. And then there's the question someone asked in the last session about, is it accurate enough? There's no simple answer for whether or not OpenCap is sufficiently accurate. It depends on which metric you're extracting, how sensitive, how accurate it needs to be for your research questions, what part of the body you're measuring, the specific number of cameras and the placement of the cameras, even the environment that you're in and what the participants are wearing. All these things can make a difference. The best way to know for sure is to prototype your own data collection and test to see what works best. And that brings us to step two. We strongly encourage you to test out, even just with healthy controls as your first participants, unimpaired participants, and members of your own study team. This is a great chance to work out the kinks in your protocol and make sure you know how to iron out all of the difficulties in collecting data. In our case, we had this set of 9 activities, and testing the protocol helped us to identify which activities were the best ones to include. And this is also a great chance to create a script to provide instructions to the participants, because the specific wording that you use to describe the tasks can really impact how they perform the activities. And you want consistency both across the participants and also if they come back multiple times. You want them to perform the tasks the same way. Testing is also the right time to test how long it takes to perform the protocol, because once you know the duration of going through all these tasks, it'll help you to plan your large-scale data collection. The next step is to pick a location. This is a floor plan we used when we were preparing a data collection on one of the Stanford gymnasiums. So in this particular case, we had a curtain set up between the basketball courts because our participants, it would help to provide a little bit more privacy for our participants who are conducting the study. We set up tables for check-in and for filling out paperwork and put them next to wall outlets so that we could power laptops and other electronics. And we also created a seating area for people who were waiting to do their data collection or for family members who came with them, and some snacks to make them comfortable. We set up multiple capture stations. In this case, in this study, we had 5 stations. We had some long stations for doing gate trials and some smaller stations for doing stationary trials. We had 2 gate trials and 2 stationary trials, and we also had an extra station that's labeled AX here. We did that because we knew that the gate trials tended to run a little bit more slowly, and so if we ran behind schedule, we wanted to be able to have an overflow station. It was also helpful for us to have multiple stations so that if there was any technical difficulties and we had to recalibrate a setup, we could just switch over to another working station without falling behind schedule with our flow of participants. So just seeing the layout is helpful for planning where people are going to go and how much space you need. Also, because these stations are now pretty far away from the power outlets, we knew we wouldn't be able to stretch charging cables without creating tripping hazards. So we put portable battery packs at these stations to keep everything charged. This kind of layout is also a good chance to think about the field of view of your cameras. So for example, in this case, we noticed that our cameras would be able to see people in other capture stations. So someone at the base of station A2 might be visible in the background of the videos from station A1. And so to fix that problem, we added some portable photography drop cloths in the scene to occlude those side paths. Planning like this, it's also important to check the location before you start your data collection to make sure that the Wi-Fi is strong. Remember, OpenCap records videos and uploads all those videos to a cloud server. And so during your data collection, your phones are going to need to have good Wi-Fi connectivity to upload all those large files. If they're slow, then it will change the pace of data collection, especially when you have so many phones connected at once. So when we started our data collection, we actually brought all our phones to the gym and connected them at once and made some simultaneous recordings just so we could stress test the Wi-Fi. Once you have a plan for your layout, it also helps you determine how many staff you're going to need, how many personnel you'll need during the data collection. So if you want to have 4 simultaneous capture stations going, that means you need to have staff for all 4 of those stations at the same time. In this particular data collection, at any given time, we always had at least 2 people at the check-in stations to help people with their paperwork. We had 4 people just operating OpenCap, so that's starting and stopping recordings, recalibrating trials if necessary, and organizing the space, labeling the trials. And then we also had 4 people who were instructing the participants in their activities. So that's showing them where to stand, explaining what to do. And in our case, those people also recorded those time function tests simultaneous with the OpenCap recordings. We also had at least 1 person just floating around, able to fill in any role as needed, and also a person who drove a golf cart because some of our participants needed help accessing the gym from the parking lot. So once you have a clear plan and you've scoped out the location, it's time to recruit and schedule participants. Scheduling can be a little bit tricky, even if you know how long you think it's going to take. It's hard to predict exactly what's going to happen on the day of. On the one hand, we encourage you to be ambitious with the scheduling, because once you've already set up this location and recruited all your volunteers, you want to make the most of your data collection day that you can. So you want to schedule in as many people as possible. On the other hand, you have to also prepare for the unexpected. So we recommend scheduling some breaks in the schedule where you can either allow your study staff to just take a break and get something to eat or stand up and stretch. And also, if you're running behind schedule, it's a chance to catch up again. We've also found, as we've done these data collections over the course of multiple years, every year it goes more and more smoothly. So you might be surprised just how efficiently you can collect data this way. The next step is to prepare materials to make it run smoothly, especially with so many people, so many different volunteers, and needing to orchestrate all of their roles. We had a lot of documentation to try to make it easy for volunteers to know what to do. We had station setup checklists that had equipment lists that they needed to make sure they assembled at each station, and steps for setting up in the morning. We also had detailed data collection sheets where our volunteers could record information to put into the OpenCap system, take clinical notes, write down their participant IDs, and we also had detailed scripts that we wrote out with boxes to fill in the time function test scores and check boxes for which tasks were complete. So this kind of paperwork helped us to stay organized and make sure that we were consistent with how we performed all these tasks across people. It's also important to make sure that we've prepared all of the volunteers and the participants. In our case, we made some training videos to help them. So we made some training videos for the OpenCap operators to teach them how to use OpenCap. And we also did in-person training for about 15 minutes for each OpenCap volunteer to make sure they were proficient with the technology. We made some videos for the participants too, explaining what to expect and what the data collection was like, and reminding them how to come prepared, including what to wear and what to bring. All of that preparation just helped us to make the data collection run smoothly once the day arrived. And now it's step 8. So once you've done all of this pre-work, it's time to actually do the data collection. Hopefully everything will go really smoothly now because of all that careful preparation. Data collection is a lot of fun. Doing this kind of research has been some of the highlights of my PhD because it's a very unique chance to get people with lived experience with disease and engineers and clinicians all in the room at the same time collecting data together. And there's something really exciting about doing research at this scale that's pretty unique. After you've collected the data, it's time to do all of the quality assessment. So, having large data sets also means a lot of work to curate and maintain that data. And so I mentioned in the last section, we have over 450 participants and well over 5,000 recordings. And we have manually checked all of those recordings to make sure that we know which ones were successful. So, for example, here's a video of an unsuccessful trial where something went wrong with the kinematics. When something like this happens, you have to decide, is it an error that's negligible that you can ignore? So, for example, maybe there's an error with the upper body kinematics, but you're only studying lower body kinematics in your research. It might be an ignorable error. There might be some other errors that are problematic but fixable. So you might be able to, for example, trim the videos to remove a part of the video where someone walked into the camera frame, or you might be able to reprocess it locally to recover good kinematics. But there might also be some kinds of errors that are just unrecoverable. So for example, if the videos never got uploaded to the server, you're just missing that data and there's nothing you can do. We also encourage you to make sure you check for the types of errors that might sort of pass silently through. So in particular, if you just watch a video and the kinematics look okay, there might still be some error that either happens too quickly or that's too small to see by eye on a quick quality check. So as you're doing your data analysis, we encourage you to make some sanity check plots, like, for example, just plotting the peak accelerations during the trials and look for outliers and use those to track down any other kinds of bugs that might cause problems in your analysis. And then the final step is to think about how you manage and share that data. The data that we can collect with OpenCap is extremely valuable, both in terms of having large studies for your own research, but also to really unlock the power of this type of biomechanics data. We think there's great scientific value in sharing our data to do open science. We take privacy very seriously with OpenCap because we're working with identifying patient videos, and we give participants the option, if they care to share their data, either the videos or just the kinematics, with these larger data sets so that we can train large foundation models and try to advance both the science of human movement and also design new technologies for measuring human movement. I hope those 10 steps are helpful. Every individual research project is a little bit different and the details will be unique to you. But to give you a head start, we've provided a resource packet with example documents that includes many of the things that I just showed you here and some other documents you can adapt to your own use cases. And hopefully some of the considerations we've thought about here can help you scale up the quantity and the quality of your own OpenCap data collection. I'll go ahead and break there for more questions.
Great. Thanks again, Parker. So we'll go ahead and switch back to questions. There was one from the previous talk that we can answer right now, and as more come in, we can answer as they come in. So Anshuman Mishra was asking about can OpenCap reliably detect subtle movement compensations that are observed in early stage injury or rehabilitation?
That's a great question. I would say that's still an open research question for us too. The early stages and the sensitivity are the key questions there. In order to know that, we have to have enough data that we can measure ideally not just the difference between healthy controls and people with disease, but also tracking the longitudinal change over time. And so we've been doing data collection now for more than 3 years. So we have some longitudinal data we're currently analyzing. And we're also very interested to know the answer to that question.
Uh, Gabriel Pate was asking, can OpenCap maintain accurate motion capture in outdoor environments where lighting and background conditions are less controlled?
Yeah, it's an excellent question. So OpenCap does work outdoors. In fact, that's one of the great advantages of using smartphone-based motion capture is that you're not tethered to traditional motion capture laboratories. The lighting and the background do make a difference. In general, it helps if, I guess to put it simply, to record OpenCap well, you don't want your subject to be camouflaged in the scene. And so you want good contrast so that the computer vision algorithm can tell the difference between the person in the background and can see all the body parts of the person. So as long as that's true, we've had success doing data collection on the track, for example, outdoors, not for this study, but for other research. So again, we'd say prototype it yourself, check to make sure it works, but we're optimistic that it will work for your use case or that there'll be a way that you can adapt your setup to make it work.
So Philip Bekonovich was asking, how many personnel did you need to check and curate your data, and how did you organize those roles?
Yeah, it's an excellent question. So it takes a lot of work. A lot of the data curation has been done by myself and by another PhD student in our lab. And it takes a long time, but it's well worth it. It's useful for us also because we're the same people who are doing the downstream data analysis, extracting features and making plots and doing statistics. It helps us to actually see the videos themselves so that we understand what we're designing our later data science pipelines for. But in terms of organizing the roles, we keep a giant spreadsheet that has 5,000 rows in it for every one of the recordings that we took. And we mark which trials were successful and which ones had errors. And if they had an error, we annotate what the problem was. And many of those errors we've been able to go back and successfully fix by reprocessing, by trimming the trials, or by doing something else. And so that's how we've done it. In terms of what works for your own team, it depends who's doing the work and who you're trying to coordinate with. But the important thing is to stay really organized, because as you update the trials and create new versions of files, you need to make sure that you know where the updated files live, what's already been processed, and what your decision was about whether to include or exclude data in your study. And then, of course, when you're writing up your results, you want to be able to go back to that through that audit trail to know how you decided what to include and exclude.
And I'll maybe add to that question because that's about the data analysis. Like, maybe also, do you want to speak to how you filled out personnel roles for data collection, or like how many people you felt you needed and adjustments you had to make there?
For sure, yeah. So during the data collection stage, when we're actually recording data, we chose the number of personnel based on basically rehearsing before we started. So in our case, at any given station, we decided to have one person just focused on instructing the participant in what to do, and then have a second person who's just operating OpenCap, so starting and stopping the recordings at the right time and labeling all the trials correctly. That division of labor was helpful for us. It's possible to have one person do both tasks. So you can tell a person what to do and then press the start button. It's a little bit more multitasking, and there's a little bit more risk for making mistakes because you're doing so much at once. But because we were able to bring in a lot of volunteers who, just friends of the lab who were willing to help us do our data collection, we preferred to have it be a little bit more, have a higher staff to participant ratio.
This is kind of a large question, but if you can pick one out, this is Peter Aldano. What would you say the biggest obstacle was that you had in the entire process? Or maybe you can highlight a few big obstacles that you had to overcome.
Sure. I mean, that is a big question. There are definitely a lot of challenges in every kind of research project. I think one of the biggest surprises for us that really came clear as we were doing this study is that OpenCap has shifted where the bottlenecks are in doing research. So it used to be data collection was the bottleneck because taking the time to bring people into laboratories, conduct studies, and organize that data was the slow part. Now, data analysis is actually the bottleneck because collecting data is so easy, and we can collect, relatively easy. It still takes a lot of work and time, but we're able to scale up our data collection very rapidly. And now things like quality assessment and analysis actually provide the bottleneck. Like we had to slow down our data collection at some point because we realized we actually needed to spend more time just processing the data that we already had, which is terrific. It's a great new problem to have because it's shifted where our time can be spent away from just the operation of collecting data to trying to actually extract new insights from the data that we have.
Um, G-Chan had a question, and I think you can maybe touch on a little bit about how, I mean, we focused on the digital health days in the gym, but also like how you can potentially duplicate this protocol in other areas, like, taking it to conferences and et cetera. But the question specifically is there any possibility to collaborate with your team on doing longitudinal studies on local assisted living facilities in his area? But,
Yeah, we're very interested in helping other people do the same kind of data collection, and we would love to roll out to other sites. The important thing for us is that we want to increase both the number of recordings over time, so we have more longitudinal data, and also increase the number of participants enrolled in our study. We found because the diseases that we're looking at are pretty rare. After running digital health days here at the Stanford campus, we've collected data from pretty much everyone we have access to recruit in the Bay Area. And so in order to increase our population more, we travel to conferences in other parts of the country and even other countries to recruit more people. So that's been helpful. And then from the longitudinal perspective, that's very useful for us to be able to track not just differences between people, but how these diseases progress over time and how much variability we see within a person versus between people. And we're very excited to have other people be able to do this kind of data collection and contribute to larger multi-site data sets.
and maybe we can just speak real quick to the data sharing options. Aubrey Grove had a question about, do you have the option to not share the data? Or you mentioned an option to not share the data with the participants. Does that include videos? For example, if I have an IRB protocol in place for videos I've collected, what would you recommend?
Yeah, so the specific use case for your study kind of depends on what you're doing. There's some helpful information on the OpenCap website. If you go to the OpenCap website, scroll down to the very bottom, you can see data and privacy information there. So that if you have questions about what to write in the IRB, there's some really helpful documents there. And yes, you're right. Participants have the option not to share videos. The videos do get uploaded to the cloud. So in order to use OpenCap, the videos have to get stored on the OpenCap server so that we can process them, but they will not be shared with other researchers or included as part of training data sets without permission. And the details about that, I think, would be online.
Yeah, definitely. Um, let's see. Yeah, just quick. And Aubrey Grove also had another question. You can just touch on in terms of the settings that you use. They mentioned that they saw that OpenPose was used for 2D key point detection in monocular. Is that the same in OpenCap, or did you use the same pose detection for?
So in my study, we have always used multiple cameras. So I haven't used the monocular OpenCap for the study I presented today. I know at least for the multi-camera OpenCap, you can choose to either use OpenPose or HRNet, which are two different pose estimators for that first stage of analysis. And you can also, if you reprocess your trials locally, you can use whatever pose estimator you want. If you download the OpenCap processing, OpenCap core code and OpenCap processing code yourself. So in our case, I believe we used HRNet for most of our recordings.
Oh yeah, this is a good question. So Katie Day, is OpenCap data compatible with OpenSim, and what sort of analyses and data sharing is available with OpenCap needs needs different software? Oh yeah, I got you. Yeah.
Yeah, so OpenCap is compatible with OpenSim. When you upload your videos to the cloud and then they get processed, you can then download the resulting files and open them directly in OpenSim and then use that for whatever other musculoskeletal modeling you want to do downstream. And they were deliberately designed because OpenSim and OpenCap are both developed by the Neuromuscular Biomechanics Lab here. They are designed to be compatible.
Yeah, for sure. And there was an earlier question about how to get ground reaction forces and center of pressure, and that's to what Parker's saying. Like you'll be able to use the data is you have an OpenSim model, you get OpenSim kinematics, and then there's some scripts on our GitHub repos to process that or to run dynamic simulations to get those estimations. Um, yeah, and Katie also had a question about how did recruitment look like and what did that process look like? Was it, maybe you can speak to it a little bit.
Yeah, recruitment, I mean, really the credit here goes to the incredible team of research coordinators who we work with at Stanford Neurology. We're very lucky that the neuromuscular research clinical research group has staff who help them do clinical research. And so there were a handful of people there who were spending a lot of hours giving phone calls and sending emails to recruit people to participate, starting over a month before we actually collected data. And then they also followed up with them to make more phone calls and emails to remind them to come to the data collection events, make sure they filled out their paperwork ahead of time, answer questions they had, make sure they came prepared, they wore the right clothing, they brought the right things. So it took a lot of work from their end of things to help us conduct this study. They also asked about recruitment. Because we were partnering with the clinical group, we were able to tap into the patients who receive care at Stanford Neurology. And we're very lucky to have access to some experts who see people from a pretty wide area. But we've also recruited people through listservs and who are part of community groups. And also at conferences, we've been able to recruit people on the spot by just setting up a station at a conference and inviting people who are attending there to join us for data collection that day.
Nicole Highmark was asking, they work with tactical populations. So does the sensitivity of OpenCap change with body-worn equipment?
That's a good question. I haven't tested OpenCap that way. I'd be interested to know what you learn. In general, the way to think about it is that OpenCap has more or less two stages. The first stage is pose detection, where just looking at the 2D videos, you try to locate the key points of the body. And so some kinds of clothing can impact the ability to do that. So for example, if you're wearing a flowing dress and it's difficult to see where your legs are, you wouldn't expect the computer vision algorithm to be able to correctly locate the positions of your knees if they're hidden. But if there's, so that could make a difference. It depends on how the tactical equipment works in your particular case. The second stage of the OpenCap processing is the kinematic pipeline, where you convert the pose data and the markers you extract from those into inverse kinematics, and I wouldn't expect that to be impacted in your case.
Let's see. There was a question from Mayanak Sharma. They were asking about interpretations of the graphs earlier, in terms of like what was on the X and Y axis. I think that more is about the joint kinematics, but I think there, like, you had two sets essentially, right? Like one is showing agreement between time functional test and kinematics, and then all the rest of them are usually by group and whatever biomechanical variable, if I'm not mistaken.
Yes. Are you thinking of this graph?
If you, I can't. If you want to share, I can't.
Oh, am I not sharing? Let me try. There was this one.
Yeah, maybe just briefly you can touch on like how to interpret that one, and then I think the next ones are all similar in terms of.
Sure, yeah. So just to walk through the axes here, on the x-axis we have a clinician-graded TFT. So this is a number that a clinician measured with a stopwatch for how many seconds it took for a person to complete this task. On the y-axis, we wrote an algorithm to extract that same number just from the kinematics. So we measured when their center of mass rose up off of the chair seat. They walked 3 meters, turned around, walked back, and sat back down again. And we measured when they touched the chair. And so the time that we measured for this task and the clinician-graded time matched. And that was true for all of the other tasks as well. And then quickly to go through these axes, the y-axis here is the number that we extracted using OpenCap, so the speed that we measured with OpenCap in meters per second, your stride length, so how long your strides are. We normalized by height because different people have different stride lengths just because they're taller, and then same thing for ankle height during swing. That's how high your ankle is over the ground while you step. And then for this one, the y-axis here is represented by that equation on the left. It's showing you this continuous measure of your shoulder elbow angle ratio. And then the x-axis here is a clinical score that was assigned by a clinician.
Perfect. Thank you. Yeah, and there was a second part of that, and that probably could be our last one before finishing up, was will OpenCap be able to provide fall risk metric in the near future or a functional ambulatory profile score?
That would be great. Actually, some of the researchers in our lab are studying both balance generally and what implications that has for fall risk. That's a great example of another application for using OpenCap to measure human movement.
Yeah, definitely. Well, yes, unfortunately, we are out of time. And thank you again, Parker, for a great talk and best practice session. And thank you to everyone for the great questions. Please be sure to click on the link that will appear at the conclusion of the webinar and take our survey. That'll help us improve the webinar series and choose upcoming topics. This webinar series is supported by grants from the NIH, including the grants that support our Mobilize and FAIR centers. We're grateful for the support, which allows us to run these webinars and other events. And thank you everyone for participating. We hope you'll continue to stay involved with our centers and that we will see you again in a future webinar. Have a great day.